Hello, hey everyone. This is Lance Lin from Penn State Biomedical Engineering. So today we are going to talk about what is gamma function. Okay, so gamma function was proposed by this gentleman. So his name is Daniel Broglie. Okay, so he is very, very famous for fluid mechanics, and he developed the so-called Broglie's principle, which is the mass foundation for designing aeroplane wings. Okay, and on the left we have the gamma function, which was first derived by Daniel Broglie. So to talk about what exactly is gamma function, let's think about two of the integration first. Okay, two of the integration first. The first one, we see this equation before. That is when we integrate from 0 to infinity, e to the power of negative s squared ds. Okay, and this function is relates to the Gaussian distribution, right? So we know the results from this is square root pi over 2, right? So how do we get this conclusion? Please check my video relates to the arrow function, okay? So this is something relates to arrow function. So what about another integration? That is integrate from 0 to infinity, e to the power of s cubed ds. What this equal to? Okay, so of course, this integration is not possible to solve with regular methods because there's no elementary function relates to this integration. Okay, but this function, this one, and this one, both of them are actually relates to the gamma function. So I'm going to show you why both of them relates to gamma function. Okay. So first of all, let's see the gamma function. So the gamma function is defined if you give any given z. Okay, you give any given z, and the gamma function is equal to the integration from 0 to infinity and e to the power of t, and then t times t to the power of z minus 1, z minus 1, and then dt. So integration is related to t. So clearly you can see here, when you give a z, you can put a z here, and then you do the integration, right? So how this thing has anything to do with this? Seems like they look very different, right? So let's write down the gamma function, in this page. So the gamma function was defined. So this is gamma function, the Greek letter gamma, and with whatever z you have. So the z here, z must be larger than 0. Okay, z must be larger than 0. So what we got is integrate from 0 to infinity, and e to the power of negative t times t z minus 1 dt. Okay, that's a definition, right? Yeah, that's a definition. So since z must be larger than 0, right? Z must be larger than 0. Let's discuss what about z equal to 0.5. Okay, what about z equal to 0.5? So based on the gamma function definition, now you have you have e to the power of negative t times t to the power of, so you got 0.5 minus 1, right? So you got negative 0.5, and then dt, okay? So that's what you got, okay? So I'm going to say that I'm going to tell you this function has something to do with this, okay? Has something to do with this. You may wonder, from first glance, these two doesn't look like each other, okay? Doesn't seem like there's any relationship between these two, okay? But I will show you indeed, this has something to do with this, okay? So how do you show that, okay? How do you show that? So you can see here, we have two, right? One is like a t to the power of 0.5, and then another one is like e to the power of negative t, okay? So we can do the substitution. Let's define t equal to, substitute as u squared, okay, u squared. So if we define this, so what we got is dt would equal to 2u du, right? 2u du. So this dt is 2u du. So what do we got? We got gamma function 0.5 equal to, let's see what we got. So e to the power of negative t become u squared, right? And then times t we are going to substitute with u squared, okay, times negative 5. And then dt is 2u du, right? So what we got here is very, very interestingly. You can see this one end up with what? With u negative 1, okay? U negative 1. And then u negative 1, u to the power of negative 1, and the u are canceled, okay? So basically what you got, you end up with is 2 integrate. So you have a 2 here, right? 2, take it to the front. And then e to the power of u squared du. Okay? So now you see this one and this one. You can see they're exact the same. The only difference is there's like a 2 before it. Okay? So then you can see the gamma function of 0.5 has something to do with error function. Okay? So then what about this? Can this also be somehow relates to gamma function? The answer is yes. This integration can also somehow relate to gamma function. But then which one? So basically, this relates to gamma function of 1/3, okay? Relates to gamma function of 1/3. Let's put into the equation and see what we got, okay? So this should equal to 0, okay? E to the power of t, okay? And then now e to the power, so 1/3 minus 1 is negative 2/3, right? Oh, sorry, this is not, this is should be t, okay? And then dt, okay? That's what we got. And then we do the same substitution. Now we are going to define t equal to u cubic, okay? Because of this, what do we got? dt should equal to 3u squared du, okay? So now let's do the substitution, see what we got. So gamma 1/3 equal to integrate from 0 to infinity. And then now you got e to the power of negative u cubic times t, right? So now t, we are going to use u to the power of 3, negative 2, 3, and then dt, right? dt is 3u squared du, okay? So now we first solve this. Solve this. What this equal to? This should equal to u to the power of negative 2, right? And then you can see, since this guy is u to the power of negative 2, and then you got u to the power of 2, so they cancel out, right? So what do you end up with? What you end up with is 3 times 0 to infinity e to the power of u cubed du, okay? So now look at it. Look at this, and then look at this. They are exactly the same, except, you have this in the front, okay? So when we say what this equal to, we can easily say this equal to 1/3 gamma function of 1/3, okay? Because basically you just move this to the other side, okay? So you got this thing, okay? You got this part is equal to 1/3 times gamma function of 1/3, okay? So basically you can use MATLAB or ChatGPT or DeepSeek to check for gamma function of 1/3, and then you got, let's say, you got the number for this, and then use this number divided by 3, and then you got the integration of this, right? You got the number for integration of this, okay? So you can see here, gamma function is a very, very broad function. When you have different z's here, it can be used to solve many challenging integrations, okay? And this gamma function is very, very important for many, many engineering subjects. So have a deep understanding of this will help you in your further study, okay? So that is all for the sharing of gamma function today. If you like this video, please check it and subscribe to the channel. Thank you.